Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 7, Lesson 8 on converting units. Now, this might seem like a kind of a strange topic to be thrown into the middle of a unit that we have on ratios and rates. And yet, converting units, which means to let's say you take a measurement that's in feet and you convert it to a measurement in inches. That's what we mean by converting units, right? To do that requires the use of a ratio and very often the use of a unit rate. All right? So we're going to see how ratios and rates get involved in converting between one unit of measuring something and another, but let's first talk about that unit issue. All right? So units are used in almost everything that we measure in the real world, right? You know, even things where it's like, well, how many chickens are over there? There's 5 chickens, right? I mean, chicken is literally the unit. I know, it seems a little weird, but you could have that, right? So we have all of these different units, right? Sometimes they're based on the metric system, sometimes the English system, sometimes like the Martian system. You know, that's not really true. But there's all these different units, and very often we need to go from one to another. So let's talk about what units maybe we use to measure some common things in exercise number 1. For each of the following, list different units you might use to measure each of the following. List as many as you can. All right, fantastic. So here's what I'd like you to do. All right, you're in 6th grade. You've lived a long life at this point, not as long as I have, but you've lived long enough that you should actually have some sense of different units that can be used to measure length, weight, and volume. I'd like you to pause the video now and list as many as you possibly can. All right, well, length has a ton of them. Now, one thing I hope that you all listed for length would be the foot, right? You know, then you've got the inch. These are both English units. The mile, that's also an English unit. But then you have something like the meter. That's a nice metric unit. Or the centimeter, right? Or the, kilometer. Right? These are all nice metric units. There's other units of length, right? Units that you've probably never even particularly thought of. For instance, you could have something like the light year, right? That's a measurement of an extremely long length, right? The amount of distance that that light travels in a given year, all right? So these are really good examples of sort of measurements we might use to measure length. Weight. There's a lot of units to measure weight, right? Here are some of them that you may have used before, right? Now in this country, we oftentimes measure the weight of a person in pounds, but we might measure the weight of something that's a little bit smaller in ounces. You've probably seen grams, kilograms. You may have heard of the ton. A ton is 2,000 pounds, all right? And again, all of these are really good examples of measurements of weight. Now, some physics teachers might get angry at me and say that grams and kilograms are measurements of mass, which they are, but we're not going there in this course. Now, volume. All right, volume you've used a lot. Ironically, some of the units you might first think about in terms of volume, things like the cubic inch or the cubic foot, right? These are measurements of volume, but probably not measurements of volume that you've really used in the real world outside of, let's say, just a math problem, in which case maybe it wasn't really the real world. But here's some other measurements of volume, right? Certainly maybe one of the most common would be the gallon, right? A gallon of milk, a gallon of gas, a gallon of orange juice. And then you could go with all the like little portions of a gallon, like a half gallon, or a quart, which is a quarter of a gallon. Right? But maybe some other things like a cup or a tablespoon, right? These are all measurements of volume, right? And every single one of them, if you gave me how many pounds an object weighs, I could eventually tell you how many tons it weighs. Or if you gave me how many gallons were in a swimming pool, I could eventually tell you how many cubic feet were in the swimming pool. Or, if you told me how far you ran in miles, I could eventually tell you how far you ran in inches by using what are called unit conversions. So let's get into that in the second exercise. Here we go, exercise number 2. Evie and Elliot are measuring the height of a small apple tree. Evie finds that it is 4 feet tall. Elliot, however, finds that it is 48 inches tall. Could they both be correct? Explain. All right, I'd like you to pause the video right now and think about whether Evie and Elliot could both be correct about the measurement of the height of this tree. All right, and the answer is yes. Basically, the answer is, well, they're both right or they're both wrong. And the reason for that is that one thing that we should know already is that there are 12 inches per foot. Right? And of course, what that is, 12 inches per foot, is a unit rate. We could even write it in its fraction form, right? We could write it as 12 inches per 1 foot. Now, remember that Evie found that it was 4 feet tall. So if we took 12 inches per foot and we multiplied by 4 feet, the feet units would cancel, leaving me with inches, and 4 times 12 is 48 inches. So in fact, 4 feet and 48 inches are the same height. So the answer is yes, because 4 feet equals 48 inches. In fact, I would claim that measurement without units is worthless. It would make no sense if somebody asked you how much you weighed and you said, well, 120, right? It would make no sense because you wouldn't know 120 what? 120 pounds, 120 kilograms, 120 ounces, 120 tons, hopefully not, all right? But you wouldn't have a sense for it. Units are absolutely critical, and our ability to move from one unit system to another unit system is a very important thing to have as you move forward in life. So let's keep getting some practice on it. All right, changing from one unit to another always involves multiplying or dividing by a ratio in the form of a unit rate. Let's play around with that a little bit in exercise number 3. At a track and field event, Sean runs a race that is 1,600 yards long. Letter A asks us, what is the ratio of feet to yards in any length measurement? State as a unit rate and use appropriate per units. All right, this is one that I claim that you should know at this point. So pause the video now and see if you can write down what the ratio of feet to yards is. All right, well, keep in mind, if you know that every yard is equal to 3 feet, there's your ratio. And in fact, that would be 3 feet per yard. Written as a fraction, by the way, that would look like this. 3 feet divided by 1 yard. Now, way trickier, letter B. What is the ratio of yards to feet? Write as a unit rate and use appropriate per unit. So now you're really trying to say how many yards are there per foot. See if you can take this answer, especially written in this form, see if you can figure out how many yards there are per foot. Well, this ratio truly is the conversion ratio between feet and yards. If it's written in this way, it's 3 feet per 1 yard. But we could always flip that ratio and have 1 yard per 3 feet. And then if I write this as a unit rate, that will now be 1/3 of a yard per foot. All right. So 3 feet per yard or 1/3 yard per foot. Really the same conversion factor. Let's take a look at letter C. If a mile is 5,280 feet long, which it is, did Sean run shorter or longer than a mile in his race? Justify. All right, well, let's go up here a little bit. We lost that. Sean ran 1,600 yards, right? We want to compare 1,600 yards to 5,280 feet, right? And the problem there is that the two units are different. So it's hard, right? If you had somebody come to you and they said, I weigh 78 kilograms, and I came to you and I said, well, I weigh 175 pounds, who weighs more? It would be impossible for you to know unless you put both weights in terms of kilograms or both weights in terms of pounds. The same issue here. I either need to have 5,280 feet in terms of yards, or I need to have 1,600 yards in terms of feet. Probably the easiest way to do that is to actually change the race length, 1,600 yards, into feet by using this conversion. And again, look at how nicely the units work out, right? I've got 3 feet per 1 yard times 1,600 yards. And again, if you want to think about that as a fraction, you can just put it over 1. Literally, the units of yards cancel, leaving you with units of feet. Now, I might have to come down here and actually do the multiplication, 1,600 times 3, right? And I'll get 4,800 feet. So that's how long Sean ran, which means he ran less than a mile. Now, of course, side note, we could have actually taken the 5,280 feet and actually really used this conversion, effectively dividing it by 3 to figure out how many yards there were, and we would find that there were more than 1,600 yards, meaning that a mile was longer than what Sean ran. In this case, what we did is we took the length Sean ran, converted it into feet, and compared it to the mile length, which is longer than what he ran. All right, so let's keep doing some conversions. So we just did a conversion between one length unit and another length unit. Another very common thing to do is to convert between 2 different time units. And a very common thing there is to convert between seconds and minutes. So let's take a look at exercise number 4. Allison times herself while running a mile and finds that she runs it in 492 seconds. She would like to know how many minutes it took her. So you could almost see this, right? You know, you've got a stopwatch, right? Allison goes out, starts running, gets done, and for whatever reason the stopwatch doesn't have a minute counter on it, it only has a second counter. So she ran in 492 seconds. Let's take a look at letter A. What is the ratio of minutes to seconds? Express as a unit rate with appropriate per units. All right, this is a little tricky. Pause the video now and see if you can figure this out. All right, well, one thing that you should know at this point, being in 6th grade, is you should know that 1 minute, I just can't spell the word minute no matter what. 1 minute equals 60 seconds. All right, those two are equivalent. We could have done the same thing in the last problem. We could have said 1 yard equals 3 feet. What that then means is if we set up the ratio of minutes to seconds, we would have 1 minute divided by 60 seconds, which means that the ratio of minutes to seconds is 1/60th of a minute per second. And of course, that is exactly the same kind of idea as saying 60 seconds per minute. 1/60th of a minute per second. All right, a second is 1/60th of a minute. Now let's take a look at letter B. Write a product that converts 492 into an equivalent time in minutes. Use division to find the answer. It will be a decimal answer. Okay, So in other words, I want to convert 492 seconds into minutes, right? And one way to really think about it is by using actually this and not this. And here's what I mean, right? You know, what we're really doing here is we're taking 1 minute per 60 seconds and multiplying it by 492 seconds, right? The seconds cancel, and what we now need to do is we need to do 492 divided by 60, and that will tell us how many minutes we have. That's not too bad. Why don't you pause the video now? There will be a decimal in your answer, but figure out what 492 divided by 60 is. All right, well, let's take a look. I'm going to give myself a little bit of extra room to do the long division here. Maybe throw the EMath symbol over to that side. All right, I'm just doing 492 divided by 60. I can kind of think about it as how many times does 60 go into 49, and that's roughly 8 times, right? Because 8 times 6 is 48, so I'll have 480. When I subtract, I'll have 1, 2. Now here comes my decimal, and I'll have to drop that 0 down. How many times does 60 go into 120? That's pretty easy. That's 2 times. 120, subtract, and get 0. So what do I have? I have 8.2 minutes. Very good mile time. To run a mile in 8.2 minutes. Very nice. Very nice. All right. Almost every single problem involving conversion from one unit to another either involves multiplying by some conversion factor, or maybe in this case, dividing by it, right? We ended up dividing by 60 as opposed to multiplying by 60. Let's keep working on this. Let's take a look at another one. Common unit conversions involve length, time, volume, and weight, all right? All of those are common. There's some other very uncommon ones, but we'll just stick to this. You will either be given the unit rate that's needed, or it should be one that's common enough that you just know it. So common ones are things like knowing that there are 3 feet in a yard, or that there are 12 inches in a foot, or there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, right? These are things that are kind of common knowledge by the time you hit 6th grade. So let's take a look at exercise number 5. Mia has a lot of apples from trees growing in her yard. She makes 3.6 gallons of apple juice from them. She stores the juice in containers that hold 1 pint. A pint contains 1/8 of a gallon. Answer the following questions. Letter A, what is the ratio of pints to gallons? State as a unit rate using appropriate per units. All right, so I'd like you to try to figure this out. What is the ratio of pints to gallons? How many pints are there per gallon? There must be something in the problem that told you this. This is not one particularly that you would have to know off the top of your head. So pause the video and see if you can figure this out. All right, well, here we are told that a pint contains 1/8 of a gallon, which means that there must be 8 pints per 1 gallon. Or you can write that as 8 pints per gallon. Great. Letter B, how many pint containers will Mia need? Show your work. All right. I'd like to pause the video now and see how many pint containers Mia will need in order to hold all of those 3.6 gallons of apple juice. All right, well, again, let's take a look at the units and the way that they all work out, right? We've got 8.6 gallons. Wait, that's not right. That's way more than what we actually had. 3.6 gallons, not 8.6. We've totally gotten the wrong answer. All right, so 3.6 gallons, and now we're multiplying by 8 pints per gallon. And Again, the great thing is the gallons just cancel and we're going to be left with pints. Now we still have to do 3.6 times 8, which is a little bit obnoxious, but no big deal. 6 times 8 is 48, 8 times 3 is 24, plus another 4 is 28. We've got one decimal place, so it looks like 28.8 pints. Now that's how much 3.6 gallons is. 3.6 gallons is 28.8 pints. But keep in mind, right, this is a practical problem. Mia is buying pint containers. So if she wants to hold all of this apple juice, she's going to have to buy 29 pint containers. Right. 28 wouldn't hold it all. 30 is more than what we need. 29 will get the job done. All right, nice practical example. Lots of apples here in the Northeast where we live. Oftentimes there's apple trees in everybody's yard and we just make apple cider. All right, exercise number 6. On a digital scale at the grocery store, Antonio weighs some tomatoes that he's going to buy. The scale tells him he has 48 ounces of tomatoes. Antonio switched the scale so it measured in pounds and tells him that the tomatoes weigh 3 pounds. Letter A, based on the information in the problem, what is the ratio of ounces to pounds? Express as a unit rate using appropriate per units. All right, see if you can take the information that was given and figure out the ratio of ounces per pounds. This is one that you might know off the top of your head, but likely wouldn't. Pause the video and take a few moments. All right, well, what do we know? We know that 48 ounces was equivalent to 3 pounds. So we've got 48 ounces per 3 pounds. All right, so what we need to do is we need to do 48 divided by 3. And again, you might know this off the top of your head. If you don't know it, then of course you just do the division over here. And you find there are 16 ounces per pound. 16 ounces per pound. That's why if you get a quarter pounder, right, that's 4 ounces, right? If you go to a McDonald's or something like that and you buy a quarter pounder, then there's a quarter of those 16 ounces, you have a 4-ounce burger. Let's take a look at letter B. If Antonio adds an additional 2 1/4 pounds of tomatoes, how many ounces did he add? Justify. All right, so you need to now use this conversion factor, 16 ounces per pound, and convert 2 1/4 pounds over to ounces. Play around with that and see if you can do it. All right, well, there's a ton of ways to do this. Ultimately speaking, what we need to do is we need to multiply our 2 1/4 pounds by 16 ounces per pound, all right? One way to do that, if you recall multiplying sort of fractions by whole numbers, is to actually change that 2 1/4 into an improper fraction, right? So 2 1/4 would be 4 times 2, 8, plus another one would be 9 quarters. So we actually have 9 quarters pounds, and again, all that is my 2 1/4 just switched, and then I'm going to multiply that by 16 ounces per 1 pound, right? The pounds will cancel, leaving me with my desired units of ounces. I can now do some cross-canceling. I can take that 4 and divide it into the 16 4 times, and now 9 times 4 will give me 36 ounces. All right, so 2 1/4 pounds is the same as 36 ounces. And that should feel about right, right? Because 2 pounds would be 2 times 16, that would be 32 ounces. And then I'd have another 1/4 of a pound, a quarter of 16 would be 4, so 32 plus 4 would be 16 ounces. That would be another way of figuring this out. All right, let's wrap this up. So strangely enough, converting units, going from one length unit like inches to another length unit like feet, going from one volume unit like gallons to another volume unit like cubic inches, all of those really just involve ratios and unit rates, and deciding whether or not we need to multiply by that unit rate or divide by that unit rate. Very often it's multiplication, okay? Not always, but very, very often. All right, so this is one of the most practical topics that you'll ever sort of deal with, because there are many, many instances in life where you do have to convert from one type of unit to another type. So you'll see it a little bit more in this course, but a lot more in future math and science courses. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.